Anthony, thank you so much for being willing to do this today. Whenever you want to get started, you can feel free.
Okay, welcome everyone to Call the Doctor event. I'm Anthony from Illinois Tech. I'm gonna kind of talk a little bit about like a prototype, a direction, call it, a concept, call it, and I'll be like right out of the gate say I was more like interested of with so many open source models left and right, and there's a lot of things on the internet about like intelligence and what's better, and there's benchmarks and things like that. It's almost like, how can I actually like see what's, you know, this intelligence like quantifiably, and is it useful, and in this open source model. So I was like designing some sort of a benchmark, and then this came along. Like, so I was like, okay, maybe this can become this. So that's kind of like the background of it. So, but we'll talk a little bit about how we do things today, the data to AI kind of like paradigm, and then I'll kind of present this concept of like bring the AI to the data. And a little bit we'll talk who benefits from this kind of, I guess, approach. And I'll cover a little bit of the LLMs and basics like for agents and things like that for the audience. I don't know how well versed is the audience. And some of the things I've learned, like building this and kind of working with it and understanding limitations and what can we do with all of that, and how can this fit into the data management kind of community, if you will. And then kind of like I'll show you a little bit the single file or folder. I'm open to suggestions from the community, like agent, SFA-HDF5 is the first kind of implementation of that kind of principle, which again, for this very first thing, we're gonna only be like talking about this prototype, and kind of the objective is to kind of follow FAIR principles, and I'll go through a live demo at the end. And then maybe, you know, kind of start the conversation with the community, right? So many of you like been there. Do we have like a laser pointer here? I think somewhere, laser pointer, whatever. You see the mouse? So, you know, we all seen this kind of like interface, the chatbot interface. We like upload certain things or whatever. They even have a bunch of connectors now, and they're pretty cool. I mean, if you remember the day back in the day when they started releasing, it was like really primitive, the way, you know, they would like upload things, understand the things and things like that. Right now, I mean, of course, these guys have gone crazy, the industry, and so a lot of these bots are really advanced now, but still, you know, the interface is like you upload a file and, you know, ask a question. And it's great, like when it works, like, you know, you give it Excel files or like whatever, like text files, and you like summarize this and that, it's like magic. It's like great. One question here is, hey, are we comfortable like sharing some of the data with this kind of random companies that provide AI? And, you know, kind of like at this stage of development of AI, and most of these vendors are kind of like data hoarders, right? Like everything we put at these bots, they like everything becomes their property, and they're like training things. Plus the whole thing that, you know, nobody guarantees you, like, you know, the whole mistakes and all of that kind of stuff. So we all been there. And then sometimes we're comfortable, sure. Like, you know, and then another bot like here, an example, I'm like, let's see, like, let me upload this HDF5 file, and it's just a very simple file, and just ask like a question, and boom, immediately I get, hey, file unsupported. Like, what are you asking me? Like, where is this H5 file? So, no, naturally you ask, should we like, how are we handling this whole sharing data with it, and what are the limitations, and a lot of this kind of framework, which a lot of the community is like looking into. And this is very primitive for me, but it was like trying to frame the problem here. And so there are like a lot of issues I've seen, like data size limits, like you can't really upload anything you want. There's a lot of like loss of context, you know, across the chats and across when you like upload things, and, you know, like it kind of loses the important data context across the, you know, the conversation. It wasn't designed actually to be, you know, a data front end or anything like that. And of course, there's the security issue, privacy issue. Like, are we comfortable? What are they doing with that? Like, you know, all of these kind of things. And finally, the more kind of motivating thing is that you're kind of limited to this one-shot query. You're like, hey, like, what is in this file? Or what kind of groups do I have in this file? And then maybe it will work, maybe it will not. Most of the times it doesn't, most of these chatbots and stuff like that. And again, we're like gonna highlight the limitation. Is that intelligence limitation? Is that tooling? Is that how we package this like a data pipeline and intelligence, like feed it to intelligence? Like we'll have to like find out. So again, the premise here is imagine a different approach, right? Like what if we could bring the intelligence to the data? Like, so, you know, that's kind of like the premise here. And then intelligence has a lot of kind of like flavors, and maybe you're all aware of this kind of dynamics in the industry right now, or like the way things are going. But, you know, I kind of classify it this way in a sense, but, you know, feel free to pitch in ideas here. You know, you can have local AIs, like local LLMs, and, you know, I have a computer here, a desktop, like I'm connected to it right now via SSH, and I have a GPU for gaming. I'm a gamer, and I'm running all Yamas and LM Studios and all kinds of like local providers, like, and I'll refer them from now as like, this is just vendors of intelligence, right? Like providers. And of course you can have a private cloud, like think of it like, you know, your cluster at the university, for instance, maybe, you know, I can run some of the Oyama stuff there, and then I can call that because it's a bigger machine, and I can kind of like still private, still like I own that. I mean, my lab owns it, my institution, but you know what I mean. And then institutional AI, like, you know, here's where, you know, we can pitch in like Argon's effort for like Aurora GPT. I don't know how they're thinking to deploy it, but thinking they're going to have an endpoint and some sort of like an API, and you call it, like you're a scientist there, you're working on your workstation, like, you know, like I guess this is where we're going. And then kind of like the industry is proposing this hybrid intelligence model where, you know, more and more actually I believe on it. Like you have your terminal, your like a computing device having some local AI capability. Then you see companies like Apple releasing Siri in this kind of hybrid world where there's like this Apple cloud first, where, you know, they're ensuring your data is secure, and then only for world knowledge, they're like pinging ChatGPT to get like intelligence from outside. So like there's a lot of this kind of effort, which I believe in it. Like, you know, I believe we should give that to the scientists, like where a lot of these AI intelligence providers, like they're like mixed and match. And so this is kind of like some of the properties I try to instill in this project. So hybrid intelligence, bring your own LLM, and then, you know, the AI will operate within your data environment. Okay, I'm gonna go fast because I talk too much. I'm excited. I'm passionate about these things. So this is the concept here. Like I was like, how do we deliver that? How do we deliver that intelligence on top of the file? Or like how am I doing it? Is this a service? And then I discovered Astral UV, and I love it. And it's like this package manager and dependency manager. Like you put everything in a file, and there's a script on the top, and all you have is a single freaking file. And I was like, what if this folder now, you just have a bunch of HDF5 files in there, you drop this Python script, and then just this one is the one bringing kind of like the intelligence in. It's implementing this AI-powered exploratory features. Okay, and then kind of like on top of the cherry, you know, the cake, the cherry, like, yeah, we can start chatting with it. Like if you're bringing intelligence, why don't we just expose a conversational interface, and no more APIs, no more programming. And, you know, again, the premise here would have been, for me at least, it's for my partners in the community, you're like maybe a material scientist, like sure, you're using HDF5 because, you know, a lot of these things are using it. And maybe you inherited like a code base or some sort of a repository of data files, and you have no idea what you're doing. And, you know, I'm framing this, not the technology is limited for that. My demo today is limited to that use case where you're like, you don't know much. There are going to be a million ways to do this better. If you're like an expert, if you want to write code, this is assuming, you know, the user, the end user, the scientist, the physicist, the material science, the biology. I'm just a postdoc doing this research on my algorithm. So this is the dude that this is targeting, or lady, or whatever. Okay, so a little bit of like, before I jump to the designs, like the whole kind of like property of the FAIR principles, maybe you know them: findable, accessible, interoperable, and reusable. I wanted to follow that, kind of contribute to that kind of space. You know, my team is working in the background, like, you know, publication associated with it, and we're incorporating that into a bigger scalable framework. So, you know, it's the beginning now. So it's at this stage, I want to highlight a lot, like this is only a read-only thing. It doesn't intend to kind of go and manipulate your data or like it doesn't intend to pretend to be a live service where it manipulates and monitors files. And if some other client messes with your files, that the agent knows about it. Like, no, this is like you launch this thing on a folder. It has like, it's stateless. It doesn't have databases. It doesn't have services. It doesn't have nothing. It's just, you just launch it and boom, like it can read your files. It can argue about your files and things like that. And again, I'm targeting like this kind of target demographic, scientists and maybe some developers that maybe they're not comfortable with this API. And you know, researchers, like, you know, I'm motivated with my team, and, you know, new students, when I onboard them on the HDF5 stuff, you know, it takes some time, like, to get accustomed to, right? So, okay, that's it. And then a little bit of the basics, right? So, okay, on the very, very basic premises, I need to go faster, hopefully. So you have like, you know, one-shot queries, like, you know, how that works. You have your user, you know, as I said on the previous slide, like you upload your data, you issue your question, you're like, hey, like, here's my HDF5 file, like, can you figure it out? And the LLM just takes all of that, tries to process it, and just gives you back a response. We, you know, as I said, we all been there, sometimes successful, sometimes kind of crappy. Okay, well, how can we improve that? Right, we can be introduced to LLM workflows, right? So this is more like a way to predefine a sequence of steps so you can actually achieve a result, like not just a one-shot thing and hopefully the LLM will figure it out and things like that. So this one, you like tie together the LLM calls and you kind of try to manage the context a little bit, what gets into the call at every step of the iteration. And of course, this can be as long as you want. In the literature, this is going like, you know, chain of thought and a lot of other kind of chain of functions and a lot of other terminologies. But, you know, think of it just instructing the LLM to kind of like go by step and kind of like use compute time to and particular calls to achieve the goal, right? So you issue your query and then you're like, okay, now we have like first call, let's do this, and there's a result back. You go back to another LLM call, and you do some things like that until the final result is out, where you format the response and you give it back to the user. Works well, because this is more like a kind of like predefined. Like the LLM does not really have agency here. Like if you notice here, I mean, I'm looking at the other screen, and sometimes I'm crazy on the camera. So the camera is here. Hi, guys. And so the LLM does have no agency here. Like it doesn't really control the flow. Like we are the ones, like this kind of like flow, the LLM workflow is the one saying, you do this, you give me back this, you do this, you give me back this. You know, there is nothing that the LLM will decide what to do next. So that's why we categorize that as just an LLM workflow. And it works really well for a lot of cases. And most of the time, there's a wonderful article from Anthropic. I call all of you to kind of Google it. It's called Effective Agents or something like that by Anthropic. You know, one of the leading AI firms and frontier labs. And Claude is really, really freaking cool on coding. If you guys are all developers, check out, shout out to them. But yeah, this is going to be the LLM workflow, like kind of chain of thought design. And then for true exploration, though, you really need agents. And then, okay, this is a little complicated. This is my effort to work with mermaids. Forgive me, this is like really freaky. And I'll just work with this left, like right version. And it goes from the bottom up because I passed it on an AI to say, give me this mermaid graph that I want. And this is what it gave me. It's just, let's work with it. So down here, you have your user. You just passes the high level like query, like, hey, analyze this data set. Like that's what I want you to do. This is going to go into like this processing kind of logic of the agent. This is the agent. This is an autonomous decision making. Pay attention to this. Is the cool parts. So, and under this, again, premise, you can just say, hey, just a single LLM. Like once you do that, maybe just calls the LLM and boom. But on the agent, like, you equip him with a bunch of him. I personify these agents, like, forgive me, I know it's AI, I just into it a lot, like lately, and just as I talk to it, like I give him, like he's a he and all of that. So forgive me for that. But, you know, we equip the agent with a bunch of tools, like, you know, again, this could be just the API, right? You're working with the API here, like list files, list groups, list datasets, get metadata, and all kinds of things. Like this is just an example here. And then when the guy gets the query, like, okay, let's see. it will evaluate the progress. Like, let's say, what am I going to do? It will select a tool to use, let's say, whatever, analyze whatever we ask it. Do I have an analyze? I don't have here an analyze. On this example, I have a summarize. So it will be like, okay, I'll probably get the summarized data set. Like this dude is asking me about, about a summarization analyze thing. So I'll just call that. I'll get the response back, right? There's a response. Key concepts today. I don't know if you're aware of them. Maybe you are. Structured outputs, again, is a way for the LLM to only output a specific way you want it to talk. In this case, there's a JSON schema and there's a bunch of pedantic models behind to verify like all of the structured output. This was a lot of work and the community is still working, and there's a lot of levels, just another time for another day how this kind of works in the background, and it's kind of sensitive to the vendor like Oyama or like LMS Studio or whatever other vendor, if it supports, if the API supports structured outputs. But say it supports, which in this version of Oyama I'm using, it does support, or maybe I can zoom in even on this one. Then it does get back like a valid tool result, which is the output of that, let's say the H5 call. And then you just pass that back to the agent and say like, well, I found what I was looking for. And so let's zoom out again. And so, yes, my task is finished. They will pass that to a conversationalist like AI, like another agent that kind of formats things in a friendly way, because all of this time we're just conversing at structured output. So we're trying to serialize things and minimize tokens and minimize how much verbosity the LLM has. But at the end, we want to, like kind of get back this LLM natural interface that we all like and we interface. So that kind of interface agent will kind of format everything and give it back to the client. So let's do a little demo. I think I designed this to be at 200% zoom level, and then we will bring VS Code. Let's see if it's aligned nicely. Okay, pretty cool. And then I think I'm gonna bring my terminal to be able to see my GPU, like we see like the 24 video RAM, and just chilling. It's a Radeon GPU and it works well on NVIDIA. I have another NVIDIA inference server and it works the same. Just this time I'm just working on this machine now. How much time do I have?
You have about 15 minutes or so.
Okay. That gives me a little comfortable time, right? So again, this is a prototype. I'm not a good engineer. I'm just trying to put together something and like a proof of concept. And again, I said, this can be deployed a million other ways. I want you just to kind of be in this brainstorming, visionary mood right now. Like what can be done? What the community, what we all can do together for that. Okay, so let's pull up the terminal. Maybe we can start directly. Maybe I can just navigate you a little bit on this repo. It will change, of course, so maybe not. We don't need to care, but like I created a little start here script, which we can run and can launch everything for us. But another time when it's released actually, so we can start here. Boom. And so now it's gonna do a lot of things. We can like look at the output in a minute, and it's just seamless, right? Just one command. And now we're like here, we're interacting. The model has been loaded. It's not a big model. I don't know what it is. We'll have to check the conf file. I've been playing with it all morning. Okay, let's see. Let's see the output here. So, okay, we have a little message here. It's checking the environment. So all of that from one file, like, okay, it's creating a virtual environment. The file itself has, initially there's nothing in the project. And they're like, oh, let me generate this kind of like fake files for us to play with, and then of course the package stuff is installed. It creates the environment, it activates the environment, it starts the agent, right? And then the agent welcomes you back and connects to Oyama, in this case my machine. I have the default configuration to work with 5.4. We can talk a little bit. If you guys are nerdy on LLMs, I know a lot about this technology of the releases on open source, and it will be fun to play with this. I can give you insights because a lot of this is kind of try and error and fail. And really, this is coming back to what I told you in the beginning. This was a benchmark. I was like, okay, they're releasing this XYZ, Gwen or DeepSeek or Llama or all of these models. Like, can they actually perform as expected. And so I started like scaling the models, right? Like, okay, can we run it on $1.4 billion? Not dollars, I wish, I just said the word $1.4 billion. Maybe we had all of this money and we built all of that. But anyway, but as I was saying, like the billion parameters, and then 3 billion, 7 billion, whatever, like scaling up different kind of levels, and understand kind of like what kind of intelligence can you ship today. And of course, if you scale that a year ago when I was doing similar things, we have come a long way. Just FYI for the community. All right, so we're loading the model, and then boom, we're ready. Like I kind of loaded a few interesting features here, like the history, like to repeat some commands because of the testing, and I implemented a caching system. So when you do tool calls, when you work with public AI, I have a Gemini version of this. For Oyama, it doesn't matter. I can call it anytime I want, or as many tool calls I want. But for public APIs, like you don't want to overheat the API, and so I have like a cache system and a limiter, so we can test this with bigger models like Geminis and ChatGPTs and whatever other Anthropic models. I just started with Gemini, so the repository right now has Gemini tests because it's free. Thank you, Google, or whoever is out there. Thank you for letting us play with these models and the APIs you guys have. All right, so and then I get a little message there. Hi there, I'm here. I kind of to warm up the model. I kind of artificially injected a fake query there to say, give me an interesting fact about HDF5. Actually, if I had time, I can make this a little better. Like I can put like a knowledge database in the backend and then give that to the LLM and one way. There's many ways, and then when it pulls up to drive like an interesting fact or like pull like an interesting support system, it can actually reference the documentations and anything we give it to reference. At this point, it just pulls it from the whatever phi model knows about HDF5. So it tells me, hey, did you know it's designed to store and organize? It's kind of a pretty generic, interesting fact. And maybe I'm a student, maybe I don't know about that. Maybe I'm learning about HDF5. So there is value educational here as well. And so like, okay, I have like a preloaded script in the background, like to see like if everything worked fine on the script. So did I generate the files? So the files are there, and then, hey, I'm here. Now we can start asking questions. So of course you can be as polite as you want or as direct as you want. It's like, this is your AI. List files here. I don't know, hopefully it will work. It's a live demo. Okay, you see here like the GPU is spiking up. It's calling the list tools. Okay, I don't know why it's doing it twice. It's a demo. Oh my God. Okay, it called it 3 times. Again, it depends on the model. We'll talk, we'll play with it. This is a live demo. We'll get conclusions together. But the idea here was like, okay, I'm building context. There's no context here. I mean, it's interactive chat. So one thing I've learned is like, of course, one of those queries, like there's a lot of value into an exploration session, right? Like you don't want to lose the context of what you're exploring so far. So if I'm saying I'm in this directory, I'm in this file or whatever, like the LLM should have context and not lose its mind. So I had to build a lot of this scaffolding. I call it like a scaffold. Like with AI, when you work with AI, guys, we need to like definitely like figure out like the template and say, here's your framework, here's where you can go, and then just let it cook. It's pretty cool. Like some of these models can cook real good. And then anyway, so he calls the tooling and gets all the information. He's like, okay, boom, I have my results done. Synthesizing the response, and then here's your files you have in your folder. And would you like to know anything more? Okay, this model 5.4 decided to add an icon, an emoji. Okay, cool. I didn't tell it to do that. It's like a lot of fine tuning in the background. I'll walk with the code if I have a little time, like at the end, but let's play a little bit. This is another thing I added, which probably I should remove it, is too verbose and stuff. At the end, I said, ping back the LLM and give it the context of what was the chat so far, because you're assuming the user is a newbie. And so like maybe kind of ping back and give it a suggestion. What can they do next? Like, okay, what can they explore next? And so, but I think here's like too verbose. So maybe I can just tell it like, shut up, and do a little more targeted like next steps. If you read them, they make, sense in a sense. But again, it's too verbose. Okay, let's play a little bit. List groups in simple data dot H5, right? Like let's do the simple data. So now I'm like doing this, the GPU is spiking. I hope you guys see all of that. I don't know what it's doing. It's listing the files again. Don't embarrass me. Okay, repeated tool call detected. Okay, it embarrassed me. It's like, what is it telling me? All right, let's try again. Can you see what's inside? Sometimes, you know, these tools, what is inside? Simple data.h5. And then you'll see if I change the LLM, sometimes I need to like, oops, I don't have that, but sometimes I need to like give it on codes so he can understand the variable. Like, oh, you're telling me about simple data, it's 5. Bigger models, like I'm not saying 5.4 is big, it's just 14 billions, but sometimes they can infer just like, oh, you're asking about this file, right? So this is a lot of like iteration on the intelligence level and how you instruct it to use the tools and things like that. So let's see what this time is gonna be. It's gonna select the tool, the appropriate tool. It's thinking, it's listing files again, it's embarrassing me. Okay, I will change the model. Or it will change the query. Okay, I have a little bit like a tool detection to like, okay, you're talking too much and you're doing too much. Okay, let's repeat a little bit. I kind of refresh the context. Thank you, and go back again. Not start here. We can do UV run. UV run, and we just pass the directory, and then boom. In this case, we're ready to do, okay, let's do describe. Let's be a little more like, I'll be vague. What's cool about complex data.h5? Hopefully you will figure it out. And again, it's like a little refinement. This is all like, you know, growing up pains, but why is this model so slow? Maybe I should change model on the demo and use a better model. Okay, it lists the files again, and even if I ask it that this is the complex file, and then it lists the groups. Maybe it will resolve it, but I think Gwen models are the best. So I'll replace the model, and we'll see the performance again. How much time do we have? List files again. I don't know. It's just going through the loops. Get file attribute. Maybe it will tell me about this complex data.h and say, okay, let's see the attributes of this file. So this is all itself thinking again. Okay, thinking wrong. So let's stop it because again, it pisses me off. And let's look a little bit at the code. And so let's change the configuration up here. All right, so let's see. On the configuration, maybe I'll change on Gwen. What kind of models do we have? Let's see, list. Sorry, guys, give me a second. How much time do I have, Laurie? I'm sorry, if I'm gonna run.
Yeah, 5 or 10 minutes.
5 or 10, let's just choose this guy. I think it's pretty decent. Yep. All right, let's see. Where is it here? Boom. Let's try this guy, but sometimes because my GPU is small, you have to stop what's running first, and it kind of empties all the context and all the tensors in the GPU and all of this kind of stuff. So which model were we running? 5.4 latest, so stop this model. PS, okay, GPU empty, boom, good. Okay, let's go back to the Gwen model and do a loop. I didn't have pre-prepared queries. I went with the flow, guys, but you know, you get the point. All right, so let's clear this terminal. All right, so let's boot up the agent again. UV run. Now it's gonna have the Gwen agent. There you go. Gwen model exists, so it loads the model. Okay, it will take some time. I mean, it's not a huge model, but it really loads the model right now. And with this was the start script was doing that for us, and so the first time, or hopefully it will work. I don't know why it's taking so long. Usually the models load really fast. Yikes. Demo goes wrong. Okay, let's see what's going on Oyama PS. Okay, the model is loaded, so maybe I was just impatient, right? Okay, let's go back here. Loading the model. Boom. Okay, I was impatient. All right, so same deal here. What kind of fact did it give us today? Okay, it's like this, and it's designed to store the same things. Okay, whatever, you're boring. So list all files in this directory. Let's see if we are nice to him, to it. Oh, come on, I'm not a good typer. Please, let's see. Gwen, don't disappoint me. List files. Why are you calling it again? Okay, this version, I'll fix it. So, okay, cool. It retrieved the files, and then I can say list groups in complex. Oh my God. A data.h5. Please use it, do it. List groups, it's calling it directly. No confusion. Why are you calling list files? We'll see. It should have taken the response. Yeah, so these are the two unnecessary calls. Like, so we can debug it, but these are the things I'm learning, right? So the model knew how to use the freaking tool. And again, you can have access to the code and you can see it. Like, and I don't know, like this is more like about the prompting, like how I struck the prompt and the when to stop and say, hey, I got my answer, so I should like stop. And so sometimes it just infers into it and say, okay, processing complete, and then synthesizing the response. So let's see what he found. He found like an imagery and logs and blah, 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 whatever. Okay, so now let's see, list all data sets in what file we are. In this file, let's see if it has the contextual aware, if the caching works and history of conversation works. List all data sets in this file. Hopefully, it will infer we're still talking about complex data, and it will call the right tool if it's doing it so far. Do not call other tools. You got it. You got your results. Let's see. And then we can just like very quickly see what's happening. Okay, I don't know why like it's processing a little bit. And sometimes, you know, these models can be slow. Is this about tokens and your capabilities? Okay, it's calling again another tool. Hopefully it will converge at some point. Yeah, processing complete. Again, this is fine tuning then, right? So we can see, okay, here are the data sets in this file. Again, it's kind of slow, but then I can ask it to actually analyze something, right? So let's analyze some of these data sets. Let's say pressure data. Okay, I can copy this guy and say, can you analyze? This is the final, most advanced function call. So let's present that and wrap up. Data set, let's be a little more precise this time because, you know, I don't want this to fail. Oops. I want this to be, sorry, there's no terminal control. I cannot go left and right on this. I didn't implement everything. That's a pressure data from group. I'm gonna be a little specific here just to make sure I guide it a little bit from the group weather in the complex. Let's say data. Oops. Hey, come on, let's go. We're running out of time. Can you analyze this? Please do it. So this is gonna kind of try to see what's inside, like, okay, oh, I see numerical stuff, like, and I build some sort of numerical analysis and simple like statistics and this, okay, it's failing. Yeah, I don't know why it's failing. It says something about this. So maybe I can just say analyze and then just do one shot thing and infer it. Hopefully it will infer it. So let's just grab the whole thing. All right. Oops, why did I do this? I turned around. Did I copy? Hopefully I copied. No, I didn't. Oh, okay, I guess I can just type it. So analyze weather. Man, I keep forgetting I can't go back. And then what was the data set? It was, I'm missing it out. Analyze pressure data. Okay, copy and paste. And then maybe, and then I can just freaking go enter. We're running out of time. So we'll see if it's just, it will list the file to maybe check, okay, is a clarification needed. There's another thing I added to it. Like I was like, okay, maybe you can just ask it like questions, like, and then kind of recall the tools. And these are the things I've learned playing with it. And so let's go and summarize some of the properties or some of the things I've learned and then close the whole thing, right? So things like a few configuration things and some helper functions, like, okay, it's important to normalize the path. A lot of the times there's a lot of path stuff there. So I have like a few functions and some of the things, how you get back and forth the NumPy stuff and how you analyze them on strings. Some analysis functions I told you I built, like the numerical, the text. the field and then well-thought summaries and things like that. The LRU casting system, you're parsing arguments. Like here's kind of like some decorators and a little bit of the focused context, like a function I've been working on, like to kind of to tell it, hey, like we're working about this file, we're talking about that. The user expressed, so I kind of pass it to the LLM to extract intent and build the context for the next query. Tool descriptions, this is all necessary to kind of have the tools. We'll see the tools in a minute, and all the pedantic models and all the tool definitions are here. And then, of course, you have to define the tools. Like here's like how you tell the LLM, here's the tooling, here's why you want to use that, and some of the arguments and things like that. So this is how you tell it how to use H5Pi consistently. Then you have a registry, like all the tools. So, sometimes like, let me check what kind of tools do we have, and just looks at the registry, execute tool. And then here's more the main logic where you're processing the agent, you're interfacing with the agent. And as I said, this is the query goes to the processing agent and does all of the processing and the retrieval, the tool call, passes all of that to the interface and comes out. Again, some interactive mode and the query logic there, and the initialization of the client. And so, okay, fine. It's like 1,700 lines of code. I wanted to kind of make it nice for the demo, like have pretty and progress and all of that kind of stuff. If I remove all of that kind of niceness here and build a GUI on top of it, you can imagine like a very simple like web GUI, and then you just calls this tool and just presents however you want. And then you let the community build all kinds of visualizers and potentially kind of start working with this intelligence embedded to the folder. I'm done because I know I talk too much and I get excited. So questions, feedback, feel free to like give me feedback. Do I have any other thing on this? Any thank you note? No, I stopped there. I didn't have time. So I'm Anthony. Let's go back. I don't know what you want to ask, but I'll be happy to share more. And the shameless plug, I work for, and I direct a research center at Illinois Tech, and my team is amazing. And they're building a lot of these things now on a real project. It's called IO Warp. And this IO Warp is NSF funded. We're working with HDF and other partners across the community to build like a bigger platform that kind of manages data. And then one of the deliverables was some sort of an exploration interface. So you're seeing the very, very first draft of like exploration interface using natural language interfaces, and the pain groans, like what went well. So I can tell you like models up to like 8 billion, I can make them work well. Less than that, they can start like doing things that you don't want, meaning like the too verbose, or like maybe they will say, go use H5Pi. And I explicitly told them, don't suggest other tools like H5View, like we are the tool to explore. So, the LLM was like, go use H5View and you'll see what it's inside. So these kind of behaviors, like it's all about the ability of the LLM to follow instructions. Just to tell you the final conclusion, once you throw this to some like model like Claude or OpenAI or like Gemini or bigger models, this is easy peasy. It's like, this is though with my 8 billion parameter models, like a kindergarten trying to solve equations, right? And then sometimes it's like lucky, or not lucky, it's not luckiness, it's like it's doing his job well, following the instructions, but it's a toddler. Sometimes, it's hungry, it wants to go check something else, and then it loses the instructions. So this is more sensitive to that rather than how much knowledge the model has inside. Yeah, and so it's more about, and the next generation of this, you can think of like visions here, right? What if we have our own model, the HDF5 tuned model, where we tune it to be instruction following model, and then you do tool use, which is actually you're giving a proper API to the agent. And not only that, we fine tune, like this is just a base off the shelf model capability you see today. It's just, I downloaded it from the internet. Imagine what we can do if this model is a little more tuned to what we're trying to achieve here, right? Which is coming in the summer. Like I hired a bunch of students to do this work and release some sort of playground to develop agents like that. And NetCDF is coming next, and other formats can come next, and custom libraries can come next. and this can be truly scalable and modifiable. And once we figured out the intelligence injections into these exploration paths, I think we'll be good and winning. I'm done. I think I should stop presenting and you know, I talk too much. Sorry, guys. Thank you for attending and paying attention, or not. Any questions? I don't know if you guys hear me. Hopefully you're still there.
We do.
And I was not talking to the air. Yeah.
Yeah, any questions for Anthony? We'll start off with that, or on his content today. There has been kind of a lively chat here lately. So Garrett shared a link to the project you were referencing, IOWarp, as well as the GitHub link to that.
Thank you, Garrett. Thank you, Garrett. Yes, I could have finished the Excalibur board for all the shameless plugs, but yes.
Right. Unfortunately, you derailed your demo. Simple data.h5 didn't exist. So that's what derailed it.
Okay, there you go. Yeah, because I was creating demo data, simple data, complex data.
Yeah,
okay, you know, forgive me. I woke up 6 a.m. and I'm like, have 6 coffees in me, so I'm pretty energetic right now.
Yeah.
Okay, questions.
Oh, great stuff.
Okay. I really think that this can become something, and the community can like look at it and see the lessons learned of how we use intelligence in terms of the limitations. And I want to say why I package it as a smart folder idea is because, you know, a lot of you, I'm sure you had like, okay, I kind of want to use local stuff, like local AI, and then like don't violate a lot of the sharing and what I can share with public vendors and things like that. And so open source is great, and then you go into the loop of what models are good, what models are available. The companies are releasing every week. It's like constantly you're changing the next capability. IBM released this week a cool Granite model with tool use. I want to test that. I think it's good because it takes it down to 3 billions, and it works. So, you know, it's interesting space, and you know, welcome to join and experiment with me.
Mm-hmm. Are you gonna publish this code in the IOWarp content exploration engine? Or?
Yeah. This is all toy things on my own like repository, and I'll make that public for the students to play with and stuff. But eventually, I want this to be on the IOWarp, of course. Maybe not far away. Like the engineering team is already working on it. We had our own internal meetings and discussions on this kind of design principles of the deploying AI across the machines and across the platform, and they're building on it, and hopefully by the summer we'll have some good, cool results out there.
Yeah, because I mean that way we would get more contributions maybe, because this is something that will catch people's attention, and then that might be a way to, for example, well, either call HDF View from this, or over time develop a substitute that is much more powerful than HDF View ever could be. And
thank you. Yes, there's a million ideas. I have a whole like markdown file of like where we go next, right? So it's a lot of things. I can talk for hours, but we don't have the time because there's I'll drop you a gift here. There are better agentic frameworks where instead of me like specifically so explicitly listing tools and have pedantic models and all of that mess, actually the agent can just generate an API call, like very carefully though, because this is going to be failing if you don't control it. But I think I'm getting close where a 14 billion parameter model can just generate the call, and it just live on the spot, just generate a Python kind of weird, like quick H5 call, dataset this, slice that, unzip that, whatever, and avoid a lot of the fluff in the code and make it like 300 lines of code. And then now, you know, and then there's another cool framework to pay attention. Shout out to Stanford for that. It's called DSPI, which is like a programming way to interface with the LLMs. Like, you know, their motto is program your prompts. Like, so think of the LLM as a programming machine, and then you kind of pass it to the LLM. So shout out to those, because I can try these things and like maybe make the agentic thing relevant on the HDF5. I mean, in a sense of it can generate any kind of library call and retrieve data from anything and try to analyze them. And So it would be cool, like, to see a lot of these extensions and where frameworks go, LLM technology goes, intelligence, and how free it becomes. And so, yeah, stay tuned.
Mm-hmm. On your T-shirt at the bottom of the circle that we can see, it says "Life's better with IO."
At the beach, it says at the beach, right? So
No, it should say with IO War.
Oh yeah. I should have had like a better plug for our project. Yes, guys, Google us. Like, it's pretty cool stuff that's happening. Like, the team is doing great stuff. The 10 PhDs. All of them are amazing people. So check them out. Look at their publications. Yeah. Sorry for the plug. I'm proud of my team. Okay.
Cool.
I think we're here. Any other questions? I don't know if there is any from the chat, but yeah, thank you for attending, and the recording is going to be here, hopefully, so we can disseminate in our friends and family.
Yep. I'll put some of the information in the web addresses we talked about in the recording description as well, so it'll be there. So thanks everyone for coming, and next week we'll have John Reedy. He's one of our cloud experts, so see you next week. Thank you.
Bye, guys.
Bye.
Yeah. Bye.